As I'm saying, we are today we are going to cover our next topics. That is floats and a list possibly, and then the segregation is into these categories. We will be having basic data types, where we have integer, strings, floats, boolean. Basic data structures of Python are data structures in the sense it's just a structure. I mean, more than just a data type. It's just a container of element where different elements or different containers can be stored inside any of these containers. So for example, if at all there is a list is a container object where another list, it can accommodate another list, it can accommodate another tuple, it can accommodate string, integer, float, like that. These are all container sets where they'll accommodate different elements. So if tuple is there and if it can accommodate list, another tuple, dictionary set, frozen set, integer, string, float, which is the case, and list is also doing the same thing. So why do we have these many things which are doing the same thing? When it comes to storage, they have the capability to store everything. Just like I said, list can store another list, tuple, dictionary. Dictionary can also store another list, tuple, dictionary, like that. So it depends on the way it behaves. So we'll talk about that in detail. So once you're okay with this one, we'll be continuing with a more 2x speed, I can say. So I just want to make sure you guys are um, understanding more in detail about these basics. After that, we'll be dealing with looping and functions. So if you can assure me that you do not have any doubts till these topics, I can tell you one thing: you can excel in any module of Python, in any framework of Python. It may sound absurd, but it is true, because the way we dealt with strings itself indicates. So how you don't know about any object. Now, if at all you remember everything about what we have discussed on strings, so you can deal with any object that is present in Python, right? So we dealt like, so let's say a is equal to 2. So if you don't know what this object does in your code, so you'll simply print what the type of it. It says it is integer. What are the capabilities it has? It does all these functionalities. So it's quite handy to deal with any module. So for example, you imported some module. So you don't know what this is doing. I imported requests as R. I mean, the alias of this request is R. So, or let's just say import requests. So if you don't know what it does, simply you will do this. It does all these operations, right? So this is a generic way of dealing with every module or any object that is available in Python. All right. So we are touching all the things that are necessary for having good basics in Python. So I hope you still remember this integers and strings. If not, we can recap it. But I'll just move on to floats. So Python will dynamically identify the data types. And if you declare something like this, it's an int. But if you declare something with decimals, it's a float, right? So this is called as dynamic typing. You can make a note of it. So dynamic typing is a nature of a language. It is again an interview question. So by the way, before proceeding further, I have few tasks for you that are related to the strings that we have discussed in the same document. So if at all there are few people who does not have the access to the document, no problem. You can personally ping me. I'll share you the link and I'll give you the access to this document. And I'll also upload this document to my GitHub so that you can clone it, you can download it, you can use it as, whenever you need to practice. So having said that, we're back into dynamic typing. So why Python is called as dynamic typing means you do not declare any data types. So the language will automatically understand the data type. You can say this. So Python is one of the available languages which supports dynamic typing along with JavaScript. So currently the famous languages which allow is Python and JavaScript. And it does have many other properties we'll come across in parallel whenever we are discussing the other things. But for now, float. So print type of float, the regular way, whatever we did here for integers, for strings, for any other objects. So now, yes, well and good enough. It has said that it is float, but what is it doing? So this is the functionality of float. So what do I mean by this functionality? These are called dunders and or magic methods. So what is a magic method? So magic method is just another function or the ability of an object in Python which can be prone to operator overloading. And I understand that this is a bit advanced, some rocket science to understand for you guys maybe, but let's try to digest this. Maybe let's just save this for interview perspective. Do not come to this till now. I mean, in the near future, we'll discuss this after 3 or 4 sessions. What is this operator overloading? So basically, I'll give you a very high level heads up. So whenever I say f dot underscore underscore add of, it says value, right? 5.0, let's say. It will give you 2.0 is f and underscore underscore add of 5.0. In the sense, it's equivalent to 2.0 plus 5.0. That's nothing but 7.0. It's a very easiest way of doing a calculation in Python. So you're basically adding two floats. So you're adding two floats, and it is possible in Python only because of the presence of this dunder, right? So what do I mean by this operator overloading is when I'm adding two numbers, what is it happening? When I'm adding two floats, let's say, it is getting the addition operation being successfully done there. But I can make this operation do something else. Like whenever f is 2.0, g is equal to, let's say, 3.0. When I add f plus g, for now it will be float addition, but I can also make this as float multiply. So I can change the definition of this plus symbol. All right. I can, whenever you come across this plus, I can by default put a string as an output. Let's say I'll put a string of hello world. If I do f plus g, hello world will be the output. So that's called as operator overloading. Basically, we will not go into that far right now, but we can do it using operator overloading. But this can be done only to these dunders. Whenever there is an attribute, which is called as a magic method, that is present in an object, that can be prone to operator overloading. So I repeat it again. In Python, if there is an object, if you want to know more about that object, there are three things. Dir function, which gives you all the methods that an object can perform. That's one thing. Type, it gives you the data type, the type of that object, right? And then help. So let me just put this type in here. So dir will list out the methods, and help will describe all the methods. So let's say print help of f. So it says 199 lines. Let's squeeze this text. So it says underscore underscore abs self of abs. Well, this is a method and what it is doing. So underscore underscore add, it returns self plus add value. Self in the sense whatever it is. So f dot underscore underscore add of, right? F here becomes the self. So for now, forget about why f is called as self, because we did not enter into oops, but still I want to make you understand this. Self is nothing but that very object. We call it as the instance of a class. So when I am doing this f dot underscore underscore add of, I already saw the help part here, right? F dot underscore underscore add of value. It is asking for a value, right? Now it doesn't ask for self, as in you have this one here, right? So because self itself indicates f, and then value, whatever the value will give. What is the output? Self plus value. So here we can change the definition. This is called as operator overloading. We'll discuss later. I hope it's clear. So now nothing much to discuss about floats other than whatever we have discussed in integer. Same thing will repeat here. So you can just waggle around and have your normal float operations. So to be very frank, will not be using any much float operations in your production environment other than normal calculations of a simple calculator that is used between the floats. But again, to discuss more on that, same as integers. So let's say if you want 3 by 2, you'll get 1. 3 by 2, you'll get 1.5. I hope we discussed this earlier. So if it is Python 2 that you have installed, 3 by 2 will give 1.5 in Python 2 as well. 3 by 2 will also give 1.5 as well in 3.2, but in in Python 2. So in Python 3, there is a difference. For it will trim out the decimal part and then it will give. So like that, it will also support the strings here. So it will be rounded off. So this, whenever there is a slash, you may wonder, it should be 1, right? Why it is 1.0? Because a division of a float with another float will have to output another float. And just as usual, when you say 2 into 3 plus 1, there is a BODMAS rule, BODMAS. So brackets and operators, division, multiplication, addition, subtraction. So there is this is a common rule that we might have come across in SSC, inter, blah, blah, blah. So whenever there is a multiplication, it has higher precedence over addition, right? And parenthesis, which is nothing but operators, O, has more value or priority than multiplication, right? So for example, if I have 3 plus 1 here, now 3 plus 1 will be taking the precedence because it's operator, it's parenthesis, and then 2 will be multiplied. So 3 plus 1 is 4 and into 2. So same goes for float as well. Not to discuss much about that. So you can just play around. And moving back to our next data type, list. It's a basic data structure. We'll be discussing all this. Once we discuss list in very detail, just the way we discuss strings, I'll just move on a higher level for tuples, dictionaries, sets, and frozen sets. Again, if at all you have any questions or you need more explanation, you can always call out. Then we'll enter into collections, but we will not discuss much about the collections. It will waste your time. That's it. Because only in real-time software engineering, software development, pure hardcore software development, I would say, we will be using collections. So collections are used for a purpose. It's not like achieving your output. No, we will not be using collections to achieve your output just like that. We'll be using collections to optimize your code and to tune your output, right? So what are the collections in Python? There are 3 more recent collections added in Python 3 when compared to Python 2. Actually, these are all the list of collections. These 3 are added very recently. So there is something called named tuple. Named tuple is a combination of the advantages that you get by the usage of the dictionary and then the tuple. So there are advantages to opt for tuple, and then there are few advantages why you opt for dictionary. So the combination will be named tuple. So what is this and all, we'll be coming back to this later. So these are advanced topics. We'll just have to know what it is and then leave it out as is. So when you are done with it, that's why we'll enter into loops and functions. So now let's start with lists. I'll just create let's just create some session.py. This is a comment in Python, as I've told you, right? If at all you're not happy with what I am doing over here, just call me out. If you don't understand what I'm doing, I'll change my interpreter. But my first preference will be this. I'm assuming that this will not bother you. So what I'll do is, I mean, this is FYI information. This is just another IDLE, another flavor of IDLE that I use. So list is just a container. So again, type of A, how do you execute a file? Python space session.py. So now it says class is equal to list. I mean class of list. So well and good enough. I just declared a list, and a list can be declared as square brackets. I mean the elements inside a square bracket. So for an integer, how will you declare? Element without quotes. So for a string, element with single, double, triple, okay, single slash, double slash, triple quotes. You can declare with any of those in Python. So for float, element with decimal and without quotes. So for list, elements, I mean the group of elements inside square brackets. So now you can, as I've told you, you can add anything here. I'll just add integers, and the elements are separated by comma. So since I just asked the type, it gave only the type. So let me just bring it over here. So it just printed as it is, right? So now, what can I do with this? In the sense, again, the same way we debug other objects like integer, string, float, etc. We'll be having dir for this object as well. To know more about this guy, so these are all the elements. Got it? So now, these are all the shortcuts, I can say, the methods. For example, if you want to print reverse of the string, actually, let's just go back to IDLE once. That's why. So just wanted to show you this. Okay. Weird. Maybe it's not working. No. Reversed is there, but reverse is another attribute that I found here itself. Reversed, it will work. I know it. So, okay, let's try out for sort. And we'll unsort this one for now. So you'll get just a second. What happened here? This is weird. This should not return like this. A dot sort. Okay, this is already sorted. Okay, fine. A is equal to, let's say, 2, 3, 4, 5, something. I declared a list. So B is equal to A dot sort. Give me 1 second. Hmm. No, Shravan. Sort and sorted are two different methods. Oh, or sorry. So sort and sorted are two different methods. So we can use both of them. Sorted will change the original list, and then yeah, I'll just a second. I'll show you in a while. So when you use sorted off, it's a default attribute available in here and session. So this is the sorted list that you will get, but sort also should work. I used, okay, maybe my production environment is Python 2, but in Python 3 I am not sure about this. I'll check and let you know tomorrow. Actually, when I hit dir of this, you see it, right? So when I execute this, sort is there and reverse is there too. So ideally speaking, they should work. So, and sort of A will not work because sort needs to be used as an attribute of that object. So you can, if you have installed Python 3, Python 2, you can try out. It will work, but I'm not sure. Sort is giving, and it is not asking for any attribute. Not sure. So basically, ideally, it should work. So that's about sort. You can append an element into the list. How do you append an element? So like this, and print A. Let me just copy this and print just before the append happens. So if you want to add an element to a list, if you are coming from another language, what you will do is you will just do an assignment operator, just like a string. How do we replace a string? as we discussed earlier. So let's say you have 0, 1, 2, 3, 4, 5, right? And upon the sixth index, I mean, the sixth element you're planning to keep as, let's say 10. So it will be fifth index. Sixth element will be on fifth index. So because the index starts from 0 and you're appending 10 there. And then print A. This is what you'll be doing if you are coming from another language. I mean, if you want to implement some logic, right? But we have an inbuilt operator for the same, nothing but append. So even sort, when we used sorted, it automatically sorted, right? So appends the element at the end, and sorted will sort the elements in sorting order. I mean, in incrementing order. So least element will be the first. So there are, if you go to Google and search for sorting techniques, it's actually a burning topic from very long time. So there are a lot of sorting techniques available wherein, depending on the data nature, you'll have to choose which sorting algorithm needs to be used for which kind of data. And then you'll have to implement that algorithm, test it out. All right. So for example, if you see the list of sorting algorithms, these are all the list of sorting algorithms that are available, even more. This is even emerging in the market. I mean, enhancing horizontally. So they are aiming for something called time complexity, space complexity. So the efficiency of your program should improve. So in order to implement your sort, you need to implement an algorithm. But here in Python, you can implement that algorithm if you wish, if you think you are a pro. But sorted just does the job, just like we saw it, right? It will dynamically identify the nature of the data and then apply the efficient way of sorting it. But not all at all the cases. At few complex cases, you need to apply the sorting algorithm. Got it, right? So that's about sort and append. And I'll show you one interesting fact. Let's say I'll declare another B. Let's say B is equal to A. And then I'll print B. What will happen? Okay. For your reference, I'll show I am A. This is a very important interview topic. I am B. And then I'll comment this. Now when I run it, both are same, right? Now what I will do is print B dot append of, let's say 10. All right. So now I'll come back. Oh, sorry. Print. I'll come back to here and then print A, print B. Again, for your reference, I am A after B has 10. I am B after B has 10. Now when I execute it, did you sense any difference? So what happened is, whenever you changed B, A changed as well. All right. So what is happening here? So this leads to two different concepts in Python. They are very important. Even I ask a lot of times in the interviews. That is called deep copy and shallow copy. So whenever I changed B, I mean, whenever I appended an element to B, A is also changed. Why is that so? That's because, let me just comment this as well. I'll just try to print ID of A. Again, if you don't remember what ID is, so ID is nothing but the storage index of a particular object in Python. So before going to this, what ID is? There are two popular means of storages that languages choose or use. One is stack and then heap. So it's by default we'll be choosing stack for static programming, and for dynamic programming we'll be using heap. Again, what is stack and what is heap? This this may burn your brains. If at all you have any doubt, you can ask me, but I'll keep it short and light for this. We can discuss more later. So stack is nothing but, let's say, if you have a 100 pages novel, a storybook, if you want to store all those pages, it's like plucking off your pages and spreading over the table, one by one, side by side. But if you are storing it using heap, it's just like a book. I mean, a book, multi-dimensional one, wherein you can actually save a lot of space, right? Once you spread across all the papers on the table, there's no space left. Even 100 papers, single table is not enough. That's what the stack is. But it is one dimensional. So what are the pros and what are the cons? So for example, if you want to store a lot of data, you can suggest heap. But if you want to search the data, it becomes pretty much hard for you, right? Because let me just explain this. So let's say this is your stack and you have assigned A is equal to 1 comma 2 comma 3 comma 4, let's say, and B is equal to 5, let's say. So these will occupy some few spaces, right? So there are, let's say, some 1,000 or 10,000 objects that you occupied. You are having a very bad stack, very bad memory in your computer. So let's say this is your whole bunch of stack and it is all occupied, except that very too few spaces are left in your stack. Let's say only 4 elements here and there are left, right? So if you want to declare, let's say, an array again of 4 elements, you cannot do that using stack, because stack is always a continuous memory location. All right. So it means if at all you have a space for continuous 4 elements to store, then you can use stack. That is called static programming. And if you are using heap, it can accommodate dynamically 4 elements this and there with a connection between those. But then searching becomes difficult for you. So you need to link up properly using something called linked lists or dynamic data storage mechanisms that we will discuss later. But then by default, Python is a dynamically typed language and we'll be using heap. So heap is the memory allocation mechanism used in Python. So this is again another important concept. So having said that, coming back to the point, as I told, heap is the one that we are using. This element and this element are linked up, right? I mean, they can remember their addresses as well. So when I print on ID of A, save it and run it, this is the ID of A, right? So let me declare C is equal to, just a second, C is equal to 5 comma 6 comma 7, yeah, okay, some list. So when I print ID of C, save it, run it. So it's both starts with 4 and then the numbers differ, right? Because this is another completely different memory allocation, right? It makes sense. But when I say print ID of B, in order not to confuse you, I am the address of B. All right. So I am the address of C. I am the address of A. When I save it and when I run it. So if you see this, the address of B and address of A are same, right? That's what a deep copy means. It copies the element deeply in such a way that there is no actual copying happening there. So for example, mm, so for example, I declare A is equal to 2, B is equal to 2, let's say. Print ID of A and print ID of B. This is address of B. This is address of A. So if you see this, both addresses are same. So what is happening here? An object called A and an object called B are assigned here with a value. Whenever you assign 2 as the value of A, there will be an allocation that is happening to value called 2. And where is that allocation happening? So this is the memory allocation assigned for value 2. All right. So now whenever you declare A is equal to 2, there is an object A that is tagged up. It is very important concept. If you don't understand, call me out again. I can explain you. So I'm very bad at this drawing. Um, yeah. So there is an object called A that is tagged up to the already declared space, if at all it is declared. So if it is first time, it will allocate the space for value 2 and then tag along the object A. All right. But if you declare another B, let's say this one, B, with the same value, what will happen is it will first search for the value. If it finds 2, yes, it found 2 at this address, right? It will tag up only to this. That's why you're seeing ID of A and ID of B are same. So a change that happened to this element will impact all the mappings here. Got it? Any confusion? Someone can chat on it if at all you have any doubts. Any kind of it. Aarti, Sindhya, Shravan, Raji, all are clear, right? Okay, cool. So that's about the ID. And when you declare a list, when you say B is equal to A, you're not just copying the value, but you're mapping B to A, to that address in the list, right? Whenever this address is changed, all the elements will be impacted that are mapped to this. Got it? So that's why the change is happening to everything. I mean, both the elements. So for now, let's say C is another list. That is A dot copy of. So now print C. There's no other print statement. Okay, cool. Whatever. So I'll just say print of ID of C. This, okay. Print of ID of A. You all know that C is still coming from the ID of A, right? I mean, from A itself, A dot copy in the sense. This is address of A. This is address of C. When I save it, if you see this, it started with 3 and it started with 1. Got it? So these IDs are different. So what did we do? Previously, when I do this B is equal to A, you're tagging or mapping the element or the object called B to the same value. That's why it is created with the same ID. But now I used copy operation. That's why it is created with different ID. So what is the significance of it? What do I achieve by doing these two kind of things? So when I say C dot append of 21, 23, let's say, B is equal to not like aliasing, they are two different variables again. So to be more clear about it, let's say you're having some function 1 and function 2, or some code blocks. Let's say you're having some code of 10 blocks, block 1 till block 10. It may be anything, function or a class or a method, anything. So in block 1, let's say you have declared your list called A, and then you want to change, you already declared another variable called B with the same list, like B is equal to A, right? In that case, you can use that list in that block, but there is a chance in block 10, let's say, you'll be modifying list B unknowingly, but that will modify list A that is used in block 1, right? Let's say if you have some blocks of code and you're using B and A as two lists, right? So what my point is, if at all you're using in block 1 the list A and block 2 list B, and then again in block 10 you modified list B, your block 1's A will also be affected, right? So if you want that to happen, again, end of the day, there are two lists, and yes, they can be called as theoretically as aliases, but technically they are not aliases. They are again, end of the day, two different lists. So you should not use this B is equal to A. Rather, you should use this A dot copy. So I appended 23 to C. Now print C and print A, right? This is A after C is appended with 23. All right. So let me just copy this. So now when I execute this again, now C has got this appending happened and the value is changed. But this guy, A, did not have its value changed. It's not impacted. So there is use cases for both of them. You need to just drill down and explore more. So which case is, can we append a number as a second element in already existing? Yes, I'll come back to that point. So, yep, append will add the element only in the end, and there is another operation called insert, which will do that inserting operation in any index. So for example, again, if you want to know about how an insert can happen, you can always use help command, but insert, let's say 3 at 1, print A. If you do this, so you have appended at the first index the element, index, let's say A dot insert yeah, okay, my bad. So you're inserting 1 in the third index. So that's how it goes. So 0, 1, 2, 3. So if you want to insert, let's say in first index, let's say you want to insert 10, it will be like this. So it's not possible for you to remember all the attributes. I mean, hope you understand it. So it's not possible to remember every method how it works. So that's why we have help of a dot insert. So now you got this, right? So should we use insert instead of append to achieve about task? Which about task, Shravan? So inserting in the second index, yes. So appending is only for, yeah. Appending in the middle instead of last, yes. You need to use insert. So different objects, different methods will have different use cases. Appending is only for last and this insert is for index. So if at all you don't know about what it is doing, you can always have a help. So if I do help of A, I'll get all the methods. So I can do help of each object too, right? Hope it is clear. It's not only for lists, it is applicable for all the methods. And then coming back to the point where what do we use most commonly in lists? That's what I wanted to discuss more. So in real time, we'll be using count, index, reverse, append, pop, remove more often when it comes to list operations, right? So you can practice again if you want what it is doing what. I mean, how to use which thing. So you can always go here. The first thing is count, right? So what is count, what it is doing, you'll have the help of it, right? Return the number of occurrences of a given value. So if at all your list has some value 5, you can say count of 5. It gives how many number of times 5 is present. So like that, you can have all these. But for now, 4 important things that I would like to discuss is insert is done, and then append is done. And let's print this one more time so that, yeah. Yes. Here is one other interesting thing. It's another important interview question. Let's say there's something called extend. Extend, right? Oh, sorry. I wanted to know what extend is doing. So it says extend the list by appending the elements from the iterable. So something it is saying, but I understand this term, appending elements. I'm naive to programming language. I only understand appending elements, let's say. So we already have append to append the elements, right? So let's try it out. So a dot extend of 11, let's say, print a. Let me comment all these things. I saved it. So now, oh, sorry, my bad. This extend is not applicable for integers. You'll need to use strings. I mean, you can only use extend for strings. That's one point. An interview question. What is the difference? I mean, the question will be like this. Difference between append and extend. It is very commonly asked question. If you are working on Python, you will be knowing it. You should know it. That's the basic minimum expectation. So extend is appending. And again, append, let's say D, print A. Right? So when I execute it, it is still doing the same thing, right? It is appending the element, whatever we have given it at the end. So what is the difference between these two methods? Maybe you can do your background research, come back again to answer this question. So we can, or else we can discuss. I already discussed one point, that it is incompatible with integers but compatible with strings. But then that's not the major difference. There is another major difference. You can Google it out. You can practice, and then we can discuss tomorrow. Having said that, extend will also add another list to our list. Shravan, can you just explain this? I hope your audio is working. I heard it. Well, append will only add one element. No, got it. That's a good catch actually. So if you, let's see, if you append a list, let's say this, it will still work. So that's a good guess, but again, it doesn't work like that. So even with extend, you can append. I mean, you can use this list. There is one other major difference between append and extend. So having said that, the other things I leave it for you. You have the PPTs, right? And pop and remove. Again, this is something which we would in general ask if your luck is bad and if you don't remember it. It's just a basic thing which is ought to remember. That's what the interview thinks. So pop will remove the last element, just like append will insert into the last element. So remove an element from a particular index. For that purpose, we'll be using remove. So for a list, if you use pop, you'll by default pop the last element. So let's say print select print a.pop, right? So the last element in a is the list, right? This is what I'll comment for rest of the prints. So this is it. When I copy it again, when you are in the line number, step number, okay. When you are at step number 36, in the line number 36, you got your first list popped out because, let me print A first. So this is entire A, and the last element being this list. This is what it is popped out in 36 line number. So line number 37, you're again popping out. So the next last element is A. Like that, you can pop each and every element, and the last element will be popped out one at a time. So this is used in iterating the elements efficiently. So let's say, for example, you have, let's say for 1000 elements in your list. You want to iterate over all the 1000 elements in your list. So what you will do, you will write a loop and iterate one by one, right? It's a very bad practice. As a pure developer, you should follow some efficient methods, because whenever you declare a 1000 element list, you are bringing up all the 1000 elements into the RAM and then iterating one by one, which means for every iteration, your RAM is holding those 1000 elements, right? What if it is 1 million? We are in the we are in the world of big data, right? So we need to handle it in an efficient way. Sometimes your memory will hang up. So it's okay if your memory is about to exhaust with 1 million elements, let's say, and then suddenly another program comes up with another 10 million elements to be getting into your RAM. Your RAM cannot accommodate, right? So it's a space issue. So what you can do is you can use pop to iterate over, right? So what I'll do is I'll just simply write some condition while length of A is greater than, let's say, 0. And then I'll just pop the elements one by one, right? So I'll just say print that element. To avoid confusion again, I'll just comment these elements and I launch it. So you popped out each element successfully. And when I print yay now, it will become an empty list. So when I uncomment this now, it will be with elements, right? So here what you are doing is you are decreasing your space that is occupied by your RAM for every iteration. So that's one of the efficient way of iterating over the elements. It's not just confined to Python, but to every other language. So with this, I leave it to you to explore more on lists before we go further to few other interesting topics. So we'll be keeping a bit, I mean, with the velocity will be increased in the teaching level from the next session, because if you have a proper clear-cut understanding till what we have discussed now, it's like your own roadway now. You can deal with it. Otherwise, which you can always get back to me. We can discuss again. So I think that's the end of today's session. Any doubts? Stop the recording.